In this video, we're going to talk about Java's module mechanism, which is implemented using a concept called packages. If you remember, a module is simply a set of related files or classes that wish to share their implementation. That is, each of them can look at the other's instance variables and freely manipulate them. So packages are going to be our way of collecting classes into modules in Java. If you want to look at good lecture notes for this particular lecture, there's two sets. One in lecture notes, and they can be found both my notes, which is Java Modules Packages. Also, Sun has an excellent tutorial on packages. Secondly, you can go to the example code and look at the linked list problem, which is the one that we're going to be working through in this lecture. And what the linked list searching problem does is it's going to take a set of search terms that we're going to read in. So let's say we read in Brad, Nils, James. So it's going to read in a set of keywords, and then we're going to search for different terms to see whether they're on the list or not. So if you look here, this is an example invocation of the program we're going to write. The 3 indicates that the first 3 command line arguments, or the next 3 command line arguments, are our keywords to be put on the list, Brad, Nils, James. The remainder are the search terms, Jim, Nancy, Brad, and Nils. So you can see Jim and Nancy are not on that search list, therefore they will return false, whereas Brad and Nils are keywords on that search list, so we want to return or print true. So to do this, we're going to be using 3 classes. So the classes we are going to be using are going to be named search, and it's going to be our driver. It's going to be what reads the command line arguments, creates the list, and then searches for them. We're going to have a class called node, which is going to be a list node. And we're going to have a list class that is going to be a container containing list nodes. And what we're going to do is we're going to have a package which we're going to name package demo. And it is going to have the class search in it. Then we're going to have a sub-package, so let me underline it. We're going to have a sub-package that is going to be named, I believe, search list. And it's a sub-package within package demo, and it's going to contain the node and list classes. So node and list are going to be able to share their implementation because they're in the same package. We will also get into access protections and see how we might or might not share implementation with search. So let's go and take a look at our files to see how things get implemented. So first of all, we are in initially a package called package demo. That's important. A package must have the same name as the directory that contains the classes in that package. So you can see that search.java is in our package demo directory, and actually the name of our sub-package is sample list, and you can see that sample list is a directory also within package demo. And if I go to sample list and look at the Java files there, you'll see node and linked list as my 2 classes in that subdirectory. So in order to indicate that a class belongs to a package, you start its file with the package keyword and the name of the package in which it appears. In this case, search belongs to the package demo. If you want to do the if it's in a subdirectory like sample list, then you'll see that you have to fully qualify the name of the subpackage. So here, sample list is part of the package called package demo. And the package names are a comma-separated list of package names, and they're going to be converted by Java into a directory structure. So it's actually going to expect to find this particular class in a directory that starts with the name package demo, and then underneath that there's going to be a directory called sample list, and node.java needs to be in that sample list directory. Now you may also remember the import statements. Import statements bring classes from other packages into our namespace. They are just like the include .h files in C++, and in terms of bringing them into our namespace, they're a lot like the .star is like saying using namespace, say, sample list in C++. You may also remember we can specifically target classes by giving their name. So I could bring .node in. That would just be like saying sample list : node in C++. Also, you can fully qualify a class if you want. So I could also have said, for example, package demo sample list node foo equals new package demo sample list node. So those are the three ways that you can bring or that you can reference a class from another package. You can use the .star, which brings in everything from that package. You can specifically target it with the name and an import statement, or you can fully qualify it in your actual program. You should also know that if I were to say import package demo right here, it would only import search.java. So it only imports the classes directly in that directory. It does not recursively go down the directory structure and bring in classes from the subdirectory. So if I want to include classes from both package demo and from package demo.samplelist, I would have to have two statements, one importing from package demo, one importing from package demo.samplelist. The next question is, how do you actually run one of these programs? So I've already, and how do you compile them? So let's just try to compile search.java to see what happens. And you see that we get a number of error messages. It says that we're trying to import package demo.samplelist.star, and you can see that it does not think that it exists. Okay? Well, the reason is that Java doesn't know where to start its search from. The only place that it's going to start its search without being told is the current directory. The current directory, if we look, is package demo. So to try to find package demo.searchlist, it's going to start with this current directory and see if there is a directory called package demo. If there is, then search in search list. Well, if we look, we see there's no subdirectory here named package demo. There is one called sample list. So how do we make things right? The way we do that is with the class path variable. That allows us to tell, or class path flag, it allows us to tell the Java compiler where to find classes or source files. So in this case, we could tell it that where it should find sample list is in users BVZ. Actually, let's look at the full thing. Is users BVZ CS365 examples package demo. So we would say javac class path users BVZ CS365 examples. Now it will be able to find the imported package demo dot search list, because package demo is a subdirectory of examples and search list is a subdirectory of package demo. As you can see, it worked just fine. Now, oftentimes when you give it the class path, you could also have said dot, which says search the current directory, dot dot, which says search the parent directory, and in this case it also would have worked because it would have gone up to the example directory. But in general, you give full path names to class path in order to allow it to find your classes. To make an analogy, in C, you often say -I, and you might say, for example, user include. The -I flag tells the G++ compiler where to find your include files. Similarly, the class path variable tells you where to find the files that you're importing. And notice the way you separate things is with a full colon. So here you would say users, BVZ, CS365 examples, but you'd also have said dot, colon, dot, dot, and now you have 3 different places for Java to search. And it will start with the leftmost directory and work its way through the list until it finds a directory containing the classes that you have specified. Now when you run it, you may be tempted to just say, okay, Java search, and it failed. It says no class found, def found, error. So you might say, let's use that class path and give it a try. So we'll say class path users BVZ CS365 examples and do search, and it still is not happy. Could not find or load main class search. So it's still not, something's wrong. And the something that is wrong is that you have to fully qualify the class with its package name. Fully qualified. So if this was in a further thing like, say, sample list, I would have had to fully qualify it. So that's very important. And now if we try it, we are getting something else, but now it's an array index out of bounds exception because we didn't give it any information. So if I now give it command line arguments, Brad, Nils, James, Jim, Nancy, Brad, Nils, you can see it works just fine. So again, just quick recap, when you're compiling or when you're running, once you introduce packages, you need to use the class path flag to indicate where you can find the classes that are in your import statements. Now anything that you load or import from a Java library, you don't have to use the class path. It's just like in C++, when you put something in braces, it knows to look in the system-defined libraries, and you don't have to provide -I flags to find those particular files. An alternative to using the class path flag is to use the class path environment variable, and you'll have to know which shell you're using. I'm using the bash shell, so I could say class path equals users BVZ CS365 examples. Now if I say Java, give it the full package name, package demo.search, and say to Jim Brad, Nancy Brad, it works properly. If you're using a IDE, then you're going to have to look at your IDE to figure out how you can set a class path variable. Your IDEs will all provide a way to do it. So the way that Java finds the directories or the files once you have specified the class path is it goes through your class path and simply appends the imported package names to each of them. So when remember I said import package demo dot sample list. And so what it's trying to do is first see with the dot if it's in the current directory. So it's going to look to see if it can find something called package demo / example or / sample list, which it won't. Then it will look in the parent directory, so it would be like this, package demo sample list. And in fact, that would work, so that's what it would find. But let's say it failed. Finally, it would try users BVZ CS365 examples, package demo, and sample list. So that's how the class path variable works. The last thing we need to talk about is the addition of one more access level in classes. And here it's shown as default member, but it's what happens when you don't put any access protection before a variable. Remember in C++, if you don't do anything, the access protection defaults to private. But in Java, it defaults to something called package level protection. And here we've listed what the visibility is, and we will go through it. It's easier to do it if we go through an example first and then come back to this little table. So what I'm going to do is I'm going to say that I have a package named foo. We're going to say it has a class A, B is a subclass of A, E is another class that does not, that is not a subclass of A. We're also going to have a package that I call goo, and we're going to have C, and I'm going to say C is a subclass of A. So even though it's in a different package, it's a subclass of A. And then I'm going to have D, which is totally unrelated to A. And the question is, who can see A's instance variables when A's instance variables are declared public, when they're declared private, when they are declared protected, and when there is no access protection, meaning it is package level access. So as you might expect, with it being public, everything can see A's instance variables, A, B, C, D, and E. As you expect when it's private, only A can have a look. Let's skip to package because that's the next most intuitive. So at package level protection, A, B, and E can all see an instance variable in A declared with package level protection. That is, if I provided no access modifier, those are the ones that could see it. Protected doesn't work quite the way you might think. It is true that anything that is protected can be seen by A and subclasses of A, which include A, B, and C, because B and C are subclasses of A. However, protected also says that you can see that E can take a look at you. So anything that's in the package is actually also going to be visible through protected. So we can kind of look at it as going from most restrictive, which is private, then package level is the next most restrictive. So anything in a package can be seen with package. Then protected means that everything in the package can look at me, plus anything not in my package but which is a subclass. And then finally public is the most or the least restrictive. Anything can look at those instance variables. So if you go back to this chart, this is essentially, you'll see public right here, everything can look. You'll see that protected is the next least restrictive. Only, in this case, D, which was visible within which was a non-subclass in a different package, was unable to see it. Then package was the next most restrictive because everything within the same package could see it, and private was the most restrictive. This concludes the videotape on Java's package mechanisms.